Good afternoon, Chris. We're going to run your samples here today on the DM1100. Basically, I think you have seen videos of the machine anyway. This machine has been in operation for about 4 months now. It has about 150 operating hours. You see how much brush blocks we have left. They have worn about 7 millimeter of a total of 30 millimeters, 35 millimeters that you can wear. So theoretically, the way this machine has been used, you would get over 16 months of use out of these brush blocks. I don't know if this is realistic, but we will show you basically how the machine is set and how it works. So we have your parts here. I have basically sorted them a little bit by size, and we're going to start with this 078, very simple material. For that, we're going to close up the machine, lock it on both sides. We are going to very simply just turn control voltage on. On the new machines you don't need to do that anymore. We're going to turn the belt on, we're going to turn the conveyor on. We're going to run the belt at maximum speed. Basically, conveyor setting 11, and we're going to run at 4 is approximately 4 or 5 feet a minute. Actually, I'm going to increase that a little bit to 4.5. You see that the blocks are set 10 millimeters down. Which is, like I say, representing about 7 millimeters in wear, and the material thickness that on the machine right now is set to 2 millimeters or 0.78. And this is what you will see me adjusting. So we're just going to throw these on, and I'm pretty comfortable that they will come out good as long as they are all 78. Coming out. They have a good shine to them. I'm checking for temperature. They're nice and warm. Very good. And see basically, I hope that we can see that the edge quality. So, just going to stack the 4. And we are going to run them reverse. I think you will like this part very, very, very much. So, now, a very quick adjustment. We are going to move on to the next also big part. This one is 088. So it is basically only 10,000 thicker. Really, you wouldn't have to make adjustment. I'm going to make a teeny tiny adjustment basically by 30,000 and let it go. As you saw, I just made the adjustment on the lower hand wheel, just about 1/8 of a crank to the left. As you see again, we have very simple, we have a good result. I'm going to show you some changes now to some smaller parts. But I'm not sure that you want me to show you make a video of all the parts, which of course we can do. So, and if the video is a little bit awkward, I apologize for that, because obviously I am operating the machine and taking video single-handedly. So, as you see on this machine, you can multitask if you need to. When you have the parts actually in hand, I think you will really appreciate this edge quality. Oh. We're going to stack those on top of here, and now we are going to, let's run these. They are, one is 060 and one is 125. Let's start with the 060. So we're going to here, and we're just going to be adjusting that to the right by 1.5, and off we go. This part has a little bit of a bow to it. I hope that will not create a problem, but it should, because it's big enough to be held by the pressure roll. The aluminum later on, I will also increase the feed rate. This is the burr side here actually now that we are doing, but I'm still going to let it go at the same speed. Very nice. The small holes in the middle have a little bit less, of course, than the outside contours, because the abrasive lays flat on the smaller holes. So we put that on top of here. This is 0125. I'm placing it already here, and while I'm doing that, I'm going to make the adjustment to 3 millimeters. There we go. 3 millimeters. We'll be working fine now. Part disappears. Again, this machine is about 4 months in operation. Owners think we have about 120 to 150 operating hours. Edges are very good. We have some small imperfections, I think, from your cut, because as you can see, basically the cut wasn't complete on all the holes. That, of course, is dross that we cannot remove with an edge rounding machine. So now the other side. The burr side, and what I'm going to do now is I'm going to reduce it to 3 so that we get a little bit more mining action on it. So we will wait a little bit longer for the parts to come out. I'm not writing down any speed rates for these parts because you can see on the video basically how fast they are processed. Now you see even more radius on the outside on that part, and also the holes are very good other than the ones that have defects. So, let's stick with the larger parts. We have some aluminum here, which is 063. So that can go right away, but we need to change here to 1.5. There we go, 1.5. Our 063, and then the next one would be 088, and the one this is 062. So we're going to run these two together. Then we have a part here which is 088. And I will run that without making an adjustment so that you can see that nothing horrible happens even if you are 20,000 off. We're just gonna, at that point it's gonna grind a little harder. And remember, we're grinding this very slow right now and it's aluminum. On the other side I'm gonna grind it a lot faster. This is extremely round. By the way, who just came next to me here, Kirk is the owner of the machine. Kirk, you want to say something nice about it?
Dan makes a good machine and supports his equipment, and I'm very happy. So it does a great job, and it's changed the game for us. So it's a marketable product that we make upcharges on. We've sold this as an upcharge to laser cutting, so that's how we're marketing it. We're very successful doing it.
What do you predict will be your consumable cost on this machine versus doing it by hand before?
It's negligible. The abrasive cost, we were going through $15 to $20 an hour per person of abrasives, and now it's dollars per hour, maybe $1 to $2 an hour max. And abrasives are lasting so good, we're changing our calculations.
Okay. Thank you, Kirk.
Yes. Sure.
So this was a site where we were running really slow. Now we're going to bring the speed, because it is aluminum, I'm going to bring it up to 6 or even 7, which is almost 8 feet a minute. And again, we're going to run the 088 and the 063 together, because again, you will notice that it doesn't hardly make a difference. And I'm not recommending to do that, because the thicker material, of course, lifts the pressure rolls, and then you will have the thinner parts a little bit loose. But in terms of the adjustment of the machine, you almost do not need a change adjustment of the machine. And you see even here, we get a good rounded edge at the higher speed. So, last of the larger part, and no, second last of the larger part. Now we have a stainless steel.
023.
Is 023. So we are going down basically to a 0.5 millimeter on this. Not quite, because we don't want to run the belt too hard into the conveyor. And again, we're going to bring the speed down to about 5. This one.
There's a little dent here in this part.
There's a little dent.
So that'll show.
Yeah.
It won't crack.
I will run this side first, warm it up, and then I'll run that side. How hard, Kirk, how hard was it to install the machine?
Very, very simple. 480 volts, 3-phase. Doesn't use much power. Doesn't have to be level. Just concrete anchor right into the floor. We were running in a day. A little bit of duct work onto the, depending on what you do for duct work.
Right. You see the duct work that we did here, basically coming out the rear and then going into the wet dust collector on the side. Oh. You catch part.
You run it both sides?
Yeah, we run on both sides. So now we go on the other side. That's going to be a little bit interesting, because you see how the parts curve up, they are warped. And that is really something that the machine doesn't necessarily like very much, because you're going to cut harder into your abrasive block, of course. Flatten them a little bit.
Well, they're warm.
Yeah, exactly. What you always want to do, and this is the reason why you see my hand on this, you want to feel basically how warm they are, because if they're not warm, if they're cold, you're not working them hard enough. If they are too hot, you're working them too hard. So temperature is a good indicator. So now we're going to make some changes, because we're going to run some smaller parts. Here we have, again, 078 material, and it is smaller. And we want to make sure that they're holding, and they are not really super small. So the first thing we're going to do is we're going to set the machine to 2 millimeter. Second thing that we are going to do is we're going to actually bring the cross belt speed down to about 8. You hear the difference in sound. And therefore we also need to bring the conveyor belt speed down a little bit, 3 to 4. Okay? And then we have these stainless steel parts, and they do have a little bit of gloss on them. So we need to see how they come out. There they go. And the reason why we are reducing the cross belt speed, the abrasive speed, is so that the lateral forces on the parts are lower, and that the small part, even without being on the pressure roll, is holding. Kirk, what would you say, at what rate does it replace manual labor versus doing it by hand?
Factor of 10. Every bit of a factor of 10.
Every bit of a
the
factor
productivity is just amazing.
Yeah.
It's absolutely amazing. And the quality of the work, when you look at the parts, the customers just rave about the quality of the parts. Yeah. It's really put us in our own ballpark with our customers' work. it really shows.
You have been advertising this process, and you have actually gained customers because of it.
Absolutely. We're marketing to other job shops too to send their laser cut parts in, and we'll edge round for them because they don't want to make the investment in the machine. And it's a service, and the machine's so simple to operate, we can bring flexible labor in and have people that work on our powder coating line or even temps run the machine. Once the basic setup's done and whatnot, you know, a temporary operator can run the machine very successfully.
So now we are reversing them. Probably doesn't matter. You always want to run at an angle, of course, so that the cross belts only pick on a. Then you get the most consistency for the edges, and the cross belts only pick on an angle. You never can try to brush against the flat side. That would also increase the sideways force. And as you see, they come out very reliable in the same spot. And then it's working also. You see the little bit of dirt around it. When I take the part away, you see the outline. So this is basically, and most of that dirt is actually the scuff right in the brush. Now we have the same thing, just in different thicknesses. Here we have a part that is 121, which is basically 3 again. There we go, 3. And then we have 092 and 06. 092 and 060. Yeah, like that. So, while that part is going through, after it's run out, basically now we're going to change 092 on that.
This part here, you can see the piercing where you blast pierce these small holes and maybe some tabs here. You know, the machine, it will not remove that heavy dross, and Dan's been very upfront to me and everybody else, but you know, you'll need to hit that with the DA sander first. And we keep these, we use these mini Matco tool DA sanders, and the operators will buzz the part real quick, and it's hidden under the finish. So that's an op we do. We'll leave these on these parts for you to see how it comes out.
All right. I think we're dropping a part in the back here. Almost.
Yep, we're all right.
Kirk, you just also bought a belt sander from us, right?
Yes.
So basically to remove these kind of surface, this weld splash on the surface and things like that, we could easily do that also on the belt sander.
Absolutely, and it's just a matter of what, you know, our methodology is to cut the part as burr-free as possible, and the belt sanders, you know, purpose in life is where we have stuff titanium with dross where you can't cut the parts that and not get burr-free cut, or you know, steel plate.
All right, so we're going to resume. We had some camera problems again. We're now going to switch to the small parts. These parts here have an extreme bow to them. We're going to try it, but that is something that I cannot tell you that this will run successfully. And it is obviously some sort of an aircraft alloy, so we have not been successful bending it. So we're going to leave that for a little bit of later. We're going to work ourselves through smaller and smaller parts. We're going to use those. We're going to do those 062s now, smaller parts. And again, we're running belt speed 8. We're running forward speed 4. And for 060, we want to be running 1.5 millimeters on the thickness scale, right there. And then the part. Important is that the belt is warm, which it is right now from working, so that the parts get pressed into the belt, and then they will hold. And then you have underneath here, under this hatch, you can't see it right now, this is where your belt cleaning is. That's the brush keeps those belts in. And again, parts stick. They come out one next to the other the way we put them on the belt. That is the advantage of this machine over the double-sided, even though you have to run them again like we're doing right now, but you can run a small part like this, which you could never do on a double-sided machine over and under.
And that was part of my decision to buy this machine, is to weigh the costs of running the part through twice versus the opportunities of running small parts. And in our business, the small parts are awful more tedious, and we did not want that to be handwork. Whereas somebody that buys a double-sided machine, this is going to stay as handwork.
So you think this is a better job shop machine?
Absolutely, absolutely. It's just a phenomenal, very low cost investment, in my opinion, for the amount of productivity you get.
So now we simply go to 1 millimeter here, and we'll throw these on. Like I say, always at an angle, where we want to go. These are 041, also some sort of narrow space material. How long did it take your employees to figure out how to set this thing up?
10 minutes. 10 minutes of training on me. What you're watching in the video is basically the training that occurred with each of my guys. And again, once it's set up, they grasp it real quick. And once the machine's on a long production run, there's no change.
No.
The abrasives don't wear to the point where you're making adjustments while it's running.
No.
So once you're into a large stack like this stack down here, that's 3 millimeter aluminum. We'll come out and somebody will set the machine up real quick. You grab 2 guys and run it. It's very straightforward.
If you mix aluminum and other steels, how often do you clean the machine up? I mean, it exhausts into the wet dust collector, obviously.
Right. Yeah. So we're safe there. But we do a blow down. We have air real close to the machine here. You just do a quick blow down on the machine. But we're not having any problems with that. Mm-hmm. And the area, as you can see around here, stays clean. Obviously, my hands and some local areas but the floor stays clean. And the collector, we don't have it running now because we're doing the video with you. The collector is very quiet relative to what it does, and Dan also sold that to us, and it's an excellent piece, and we're very happy with it too.
Yeah, that's easy to maintain as well.
Very fairly priced too.
Okay. So now we are going to 120 thousandths, which is back to, I'm not sure what that material is.
3.
So, yeah, that's 3 millimeter, but what would you say that is? That's like an Inconel half.
I'm calling that, I'm guessing titanium. It's pretty
really
light.
Yeah.
It's pretty light. Nice cut though.
Yeah.
Real nice cut. We run a lot of titanium on here, and Dan, if this is titanium, guys, Dan put some special abrasives on this machine because that was what I bought it for. And those abrasives will also work on steel, aluminum, and stainless. But make sure if you do buy a machine from Dan and you intend to run titanium, that he orders these abrasive blocks for that material.
Yeah, silicium carbide. Can't be aluminum oxide.
Yeah, did real nice.
Very nice.
Yeah, real nice. We've been very happy with the titanium work.
Right. And that was the original purpose for the machine, if I remember correctly.
Solely, we were doing all hand work on the titanium, the dyna files and hand files, and very, very tedious work.
Right.
The other thing we noticed too with edge rounding, another benefit of this machine is, the aluminums and the, pretty much any material we're going to powder coat, is we're getting a lot of the oils and cleanliness. We're kind of scratching the surface, even though we're really not working this area. The Scotch Spray effect in the abrasive is giving us a better surface to bond to, and our chemicals in our powder coating line don't have to work as hard, and you know, we're increasing our odds of perfect adhesion. So it's a good benefit. Plus the round corners help.
The round corners make really nice paint quality, don't they?
Yeah.
So as we are working our way down, now we're getting to, this is still pretty reasonable sized parts. By now we are smaller in surface than a 2x2, which is the spec on the machine. This is an 063 part, so we need to reduce our 3mm again to 1.5. And I'm showing this back and forth the material thickness change, just to give people a good demonstration and how simple it is to adjust the material thickness. How long would you say does it take you to run this stack of aluminum here?
Oh, those parts there, you know, by hand that's going to be, one guy's probably going to be 4 to 6 hours, maybe 8 hours, going real fast.
Yeah.
2 guys could run that job in probably 30 minutes.
30 minutes, that's what I would have said, 25 to 30 minutes, that whole pallet. Yeah.
It's amazing. And being able to gang the parts up side by side is what's amazing. You really get the productivity on the smaller parts.
Yeah.
You know, big parts where you can only go one wide, yeah, it's going to take, it's way better than doing it by hand and way faster, but the productivity gains on the small parts, you can't take them on and off fast enough, 2 guys.
So,
good job.
all right.
Now there's a, you know, it looks like you guys have a tab in the part here. You know, again, that the machine's not going to remove those features.
Tabs on the side need to be ground by hand always. Nothing out there that can do that. So, same thing here, 061. Now we're getting really small. I mean, here, I'll put this on my hand so that we see that. Now it gets a little bit experimental. I don't do any warranties for that one. Seems to take it. I think we're okay. I don't hear it.
I didn't hear anything.
Yeah, it's usually, as always on these machines, you run them a lot by sound, don't you?
Yeah, absolutely. It's through. And here you can tell the test is, if it moved in the machine, you would see the abrasive, it would look like that. And it did not. So the machine held. It held, and that's very important.
But with small parts, very often it's also better not to fill the table, just to run them basically in file.
Right.
Yeah.
This belt's very tacky once it heats up.
All right.
And you know, again too, Dan said a little bit about the double-sided machine. This is impossible. It would fall into the gap of where the abrasives are. This is impossible to do on a double-sided machine. And that's what attracted us to this machine, just to be able to do this type of work. And this is just, you'll love this part when you feel it. It's a really nice part.
All right, guys. Now we're getting down to the real snuffy stuff. So we're going to run this, which is also 60, so we don't have to make a change in material thickness. And like I say, when we do that, we're going to run them in file. We're not going to run them side by side so that the pressure rolls, as they press them into the belt, have full force onto the car. One of the improvements, Kirk, that we made on the machine in the meantime, we took up your recommendation and put a screen in front of the dust collector outlets, so that small parts, if they ever move sideways, that they cannot get sucked up into the dust collector.
Yep.
That held all right.
Yes, they did.
You can hear the brushes engage even on a small part like that.
That's how
incredible.
I can walk by and tell if there is a setup problem. I can walk by and I know.
Yeah. Are your employees appreciating not having to use all the elbow grease?
Absolutely. They were blown away. The productivity just, it's mind-boggling to them. And my press brake guys really appreciate this too. Is, you know, the parts feel better, and on the press brakes we actually take more care now because the parts are so clean and nice. You have to use urethane on dies, you know, because you'll see die marks more now because you're putting a pristine part into your bending operation, you know.
Right.
So those are considerations.
So now we go. This one I don't vouch for. I really don't. It could be that we never see it again. Not sure.
I've made it through the first one.
Yeah, I made it through the first one, yeah. I think it did. Yeah. Yeah,
It turned.
It shifted.
But it
stayed on.
It feels good though.
It feels alright, but like I say, that's not a stable process.
Yeah.
So, we're going to put that out on the side. Are you going to put that back on? Okay. Why not? Kirk, it's your machine.
The worst we could do is lose it. That part, that's pushing it.
Right, it's on there.
It made it through the first one.
Yeah. Made it through the second one. Yeah. Actually, this time it held better.
Yeah.
Wow. Again, that's not the intended use of the machine, as we say so nicely in the manual.
Well, you sell tumblers. Take a video of the tumbler over there.
Right, exactly. So the last part, we only have 3 more parts to run, which are actually 4 more. These here and then the long ones. So this is going to be a real easy one, 127, 3mm. There we go. We are all set, and in goes the part.
Holes feel good on that.
Yeah. Actually, Kirk, with this one we can, if we are worried about things, we can increase the belt speed again. Yeah. And we get a bit more action.
Yeah, this is a little bit more.
Yeah, that's going to be better for the whole. So I went back to 10 on the scale of 0 to 11 for the standing belt speed. We're still standing here at 4, which is about 48 inches a minute. Die is completely gone.
Good. Yeah, real good.
Like that, right?
Yep.
Yeah, sometimes you need to play with the belt speed.
When you take a material that's 2B finished, this you know, started out as 2B stainless, you'll see the pits from the mill rolling. You can see it in there.
More of that.
Yeah.
We're going to see that on these parts.
Yeah,
right?
definitely.
In. So all we need to do here is we're going to go to 6. 6 right there. 6.4 actually for quarter inch.
And again, yeah, go ahead.
Yeah, it's not going to take that.
That won't go.
Okay, we know that already. Right. Exactly. And the round part is going to be interesting because you're going to see a slight difference based on which quadrant it is, where it's parallel to the edge and where it is. perpendicular to the edge.
You can feed them through twice on the same side and flip the grain to equalize the abrasives because of how, like what Dan was saying, how hard it's going to work edges. So now that we know this, we can rotate it 90 and feed it through again, but you know, it's definitely a rounded edge.
It's definitely basically fully deburred. You wouldn't say anybody can cut themselves on that.
No, absolutely not.
The only thing that remains still is the,
what we declared there.
The pierce. We knew that before.
This one, it looks
did a
lot
better job, but
yeah, I mean, this feels...
Again, that's not the intention of the machine on the surface. On the contrary, the intention is not to remove surface, which is why we can run galvanized and PVC coated.
Yeah, and we have done that.
All right. Now back to the bow part. With these, we're going to run them bow down first. This is not going to be a problem. It's going to run real well. And we're just hoping by putting oh yeah, sorry, pull it back.
What is this? 1.5.
There we go. We're going to put those bow down first. And then maybe when they warm up, they'll be a little bit more pliable the other way around. Not sure.
Good. Very warm.
What we will do then is, you know what? Hang on. In this case, actually, now we'll release the abrasive a little bit. We will set it back by about 40,000, which means we're going to be by about 32,000. We're going to be brushing lighter, and we also want to take the speed back a little bit.
See it move?
See, now it wants to move. It wants to turn.
And that's because of the nose of that's pointed up.
Because you're bringing it up almost a quarter inch into that brush. Yeah, they twist a little bit here. Yeah. So, not so perfect. Workable, but not, again, what it was intended to do. But the edges are good.
Absolutely, it's a good part. And then the finish just has a little twist to it, the graining.
Yeah.
This material, I feels like a titanium again to me.
Maybe it needs to be straightened before we run it.
Yeah, maybe run it through a precision leveler.
Right.
That's another, operation that would be nice to run these parts through. Titanium does both.
All right, Kirk, thank you very much. It's been another good application day at American Engineering in North Canton, Ohio.
If you need any more samples, we'll be glad to run them for you. And call me if we talked before, but call again if you need any other questions that Dan can't answer for you. But I've been very happy with the service, so good luck to you.
All right, appreciate it.
Yep.
Thank you.
Yep.